Hi guys, so this is going to be the video on Unit 7. I'm going to go over the study guide, a few of the questions from the study guide. And what I'm going to do first at the beginning of the video, it's explain to you how pretty much this, what you're seeing right now, how it works. So I'm going to explain the different meanings and the different functions of each of these variables of A, B, C, and D. I'll also explain a little bit better the period and the use of B, what they actually mean, and then I'm going to go over some of the actual practice problems. Okay, so let's begin with this. And as you can see here, you can see that A is the amplitude. So A represents the amplitude, and you can see A over here, amplitude, it's pretty much the length from the middle of the graph upwards, or you can also, it's also the same length from the middle of the graph downwards. All right, so that is your A, that's the amplitude. Now period, we can see here the period, it's found using this formula. Period is 2 pi divided by B. That's how you find the period. Then you also have the phase shift or the horizontal shift, that's pretty much moving the graph left and right. Then you have the vertical shift, that's moving the graph up and down. And then you have a little note down here saying that the same applies for the graph of cosine. So this here, it doesn't necessarily have to only be sine, it can also be cosine. And the same values apply. Then it says that for tangent, the tangent function, it's going to be, it's identical to this. The only difference, it's that the period of tangent, it's found by taking pi divided by B. So with that being said, let me show you how it actually works, like in the computer. And using Desmos, here I wrote my graph of sine. Now I let some values, I let D be 0, so there's no vertical shift. C be 0, so there's no horizontal shift. B is 1, because if it was 0, then that would cancel the x out and it'll just be a straight line. And I also let A be 1, because if A was 0, then the whole thing will be 0. So that's why it's 1. And then down here, I'm just showing you that I can have pretty much the same function, just written in a simpler way, where A is 0, A is 1, B is 1, C and D are 0. So if you notice here right now, that's the red graph for this one up here. Now let me put some color into this one so you will see the graph showing. Now it's orange. So pretty much these two graphs that you see here, this one up here and this one down here, they are the exact same graphs given these values for B, C, D, and A. Okay. Now if I start moving the graph, let's move it up. Now the red graph is going to be moved up if I make D positive. So you can see it moving up from the original spot. If I make it negative, well, it's going to go down. All right, that's pretty much the vertical shift. Let me put it back. Now C is my horizontal shift, so this should make my graph go left and right. If I make it positive, it goes to the right. Okay, but notice I am making it positive, but here in the equation this is negative. So when you write it in the equation, it'll be like negative 4.9, like 4.9 here. Put it here, it'll be negative 4.9. Okay, if you make it negative, then it's going to go to the left. But you see negative here and negative here, that will make it a positive C. Okay, that's what happens. You see the horizontal shift, there it is. Let's now put it back to 0. Okay, now B is a little more complicated. B tells you pretty much, it helps you find the period, and the period tells you the length of one cycle. Okay, the period will tell you the length of one cycle. What B does, B tells you pretty much how many times that cycle is going to repeat in that specific period. Okay, so that's what happens. B tells you how many times a cycle repeats over a specific period. Okay, so now let me explain a little more B. Well, here's one more thing. Okay, the origin graph, sine of x, this graph has a period of 2 pi. Let's go back to our paper. Okay, so the graph of sine of x has a period of 2 pi. This is, well, if you see, B here is 1, and P equals 2 pi over B. But if B is 1, like it's in this case, then you get just 2 pi. Alright, so the period of sine of x is 2 pi. Okay, let's see that now in Desmos. The period of sine of x, which is pretty much the graph, the red graph or the orange graph, the period is 2 pi, which means the graph will repeat every 2 pi. Let's check it out. It's going up, it's going down, it's going back up again, and here the graph, it's going to repeat again, starting going up. So here at this point, this is 2 pi. Okay, at this point we have 2 pi. You can see it here on the interval. It's 2 pi. And that's pretty much the length of one cycle. The length of one cycle of this graph is 2 pi. Now, if I make this B bigger, B is telling me how many times the cycles will repeat per period. So let me increase the B. Let's double it. Doubled. Okay, and let me erase the orange so you can see it a little better. And let's go back to 2 pi. Okay. There we have 2 pi. Okay, B has been doubled, so it means that because B was doubled over this specific period, I didn't change. Over this specific period, I will have 2 cycles. Okay, so let's see. I start going up, and then down, and then back up. Here's the end of one cycle. I start going up, down, and back up. There's the end of another cycle. We had 2 cycles in the same 2 pi interval. Okay, so as we start making B bigger, we're gonna have pretty much more cycles inside of this 2 pi. So let's make it bigger so you can see it's going to repeat it many more cycles in this interval of 2 pi. Let's make it bigger. And you can see we're putting more cycles in this interval of 2 pi. And 6. And here it is, 2 pi. In this 2 pi, we're gonna have 6 cycles in total. I'm not gonna count them. Take my word for it, or pause the video and count if you want to. We're gonna have 6 cycles in 2 pi. That's B. That's how it works. And again, the period, it's just the length of a cycle. A, it's the amplitude again, and that's it. Now, with that being said, we can finally go into the problems. Okay, the problems should now make more sense now that we have all of this knowledge and that we actually understand the meaning and the value of each of these letters. Okay, so let's open the problems. Here they are. So let's look at the first one. For a person at rest, the velocity v in liters per second of airflow during a respiratory cycle, breathing in and breathing out, depends on time in seconds. Okay, seconds. And it's modeled by the function of, and here's the function. Okay, so let's go to our notebook and I'm gonna write the function down. Now check the question. First question, it's telling us find the time for one full respiratory cycle. Find the length of a cycle, pretty much. That's what it's asking us for. Okay, and the length of a cycle, check over here. The length of a cycle, that's the period. When it's asking us for the length of one cycle, that's pretty much the period. What's the length of a cycle? Okay, so the function again, the one on the problem, let's then make a line here. This is going to be part A of problem 1. Okay, so let me try to make the whole thing fit into the paper. All right, so we have the function was v equals 0.85 sine of pi t over 2. Pi t over 2. Okay, and the problem was asking us to find the time for one full respiratory cycle. One full respiratory cycle, that's the period. It's pretty much asking us to find the period of this. Now look at the equation. T is pretty much in this situation, T is our x value, and that means that pretty much the number that it's right next to our x value, or T in this case, this value here, this is going to be our B value. Okay, so this is B. Now B helps us find the period, which is what we want to find. The period is equals to 2 pi over B, which is pi over 2. We need to simplify this, so you can write it as 2 pi divided by pi over 2. This is equals to, you can write 2 pi over 1 times 2 over pi. And then this pi cancels out with this pi, leaving you with p to be equals to 4. So what's the length of one cycle? It's 4 seconds. This is that's the length of a cycle. It's 4 seconds. Pretty simple, pretty straightforward. That's it. That's the length of one cycle. It's 4 seconds, because that is the period. That's how often that's the length of one full cycle, of one full respiratory cycle. That's part A. Now that was part A, 4. Now the second one, it's asking us to find the number of cycles per minute. Okay, number of cycles per minute. Okay, we know what the period is, so this is a little easier. Okay, the number of cycles per minute. So let's go back to our paper. Number of cycles in 1 minute. How many cycles are we going to have in 1 minute? So part B, problem 1. So we already know that it takes 4 seconds for one full cycle. Okay, so we want to know how many cycles are we going to have in 1 minute. Well, 1 minute, it's 60 seconds. So I'm going to take 60 seconds and divide this by 4, because each cycle it's 4 seconds. So 60 divided by 4, that's how many cycles I'm going to have. So 60 divided by 4, that is 15. Yep, it's 15. 15 cycles, or 15 respiratory cycles. Okay, 15 respiratory cycles in 1 minute. In 1 minute. Here we have 4 seconds per cycle. All right. So we have answered 2 parts. Let's see what else we have to do. All right, is there a part 3? There is a part 3. So it says the model is for a person at rest. So this is a person at rest. How may the model change for a person who is exercising? How will this problem change if the person is exercising? What's going to happen to the cycles pretty much if the person starts exercising? Well, the cycles will be faster. And as you can see on the paper here, so we're going to have faster cycles. That means B is going to be the variable affected, because we're going to have cycles repeating more often. That means B it's going to be bigger. So you can just go with that. Cycles will repeat more often. Part C, I'm actually not going to write it. Cycles will repeat more often, making B bigger. Okay, you can see it on the equation, on the graph here. If I make B bigger, more cycles will repeat. Let me get rid of the orange one. So yeah, you'll have more cycles repeating. Okay, so let's say the the respiratory cycles doubled, then B will be doubled. If it quadrupled, then B will quadrupled. Then that's pretty much how it works. That simple. B is that simple. If it doubles, B just becomes 2. If it triples, B just becomes 3. If it quadruples, B just becomes 4. Pretty much cycles will repeat faster and faster. And that's what happens when a person exercises. Breathing becomes faster, so breathing cycles will also become faster. And that's what happens here. So that's pretty much the whole thing, I think, for question 1, along with the explanation. Now we have something number 4. It says, given the function, write any function g of x which contains all of the following transformations. Okay, so let me use another paper and start writing that in a new piece of paper. So the function is f of x equals 2 times cosine of pi x minus 4. So as we can see here, this is my vertical shift, pi is b, and 2 is my amplitude. I'm not graphing, so that's not very helpful. It's helpful to know what they are, but let's see. A reflection over the x-axis. Okay, reflection over the x-axis, that's the same thing as graphing something. Let's say f of x equals x squared. Remember, if we make this into negative x squared, this is a reflection over the x-axis. It works the same thing with a graph of sine or cosine or tangent or anything. So to make it transform and make a reflection over the x-axis, I'm pretty much going to have to make this 2, or the beginning, a negative. It's going to be a negative value. Something else that I see, it's asking me to stretch by a factor of 2 over 3. Now, it doesn't tell me to stretch over vertically or horizontally. I'm just going to assume that it's a vertical shift, which will affect the amplitude. A vertical shift, it's up and down, so that will affect the amplitude. And let me show you, it's by 2/3, okay? By a factor of 2/3, it's not there, but I'm gonna say that it's a vertical stretch. So vertical stretch affects this. So I'm gonna multiply 2 times 2/3, and that will give me 4/3. 4/3. So there you go. That was my vertical shift. Then cosine doesn't change. Open up a parentheses, and then it's telling me to shift up 3 units. So that's going to affect this value. If I'm moving up, then I'm adding 3 to -4. The end value is going to be -1. I'll write that at the end. It's also telling me to increase the period, to make the period twice as fast. Well, pretty easy. And the period, that's pretty much b. If it's going to be twice as fast, it's just going to be times 2. It's going to be 2 times that pi to x. Well, there you go. That's it. Because of that 2, my period just doubled. Okay. And then this again, we went 3 units up. So this is going to become -1. So there is g of x. Okay. Period doubled. The amplitude or the stretch, we just multiply that 2/3 times that 2. There's my reflection, and there is my vertical shift. Okay, I think there's one more problem also involving transformations. Let me look for it. Yep, that's problem 8. In problem 8, we have a few more transformations, and we have this over here. So the first thing that I will do, it's pretty much to take this graph and write it down, just express it. Okay, so I'm gonna do my best to try to do this in the computer. So my graph, it's y equals, and let's find the amplitude. Okay, the amplitude is going to be from the middle of the graph upwards. You can see from the middle, from 0, it goes up to 2. So this is my amplitude from 0 to 2. That's just 2 units. So my amplitude is 2. Okay, and I see that this is a graph of cosine. Okay, because cosine starts up here on like the highest point. Sine begins at the center. Okay, so if it started at the center, this would be sine, because it starts over here, this is a cosine. So this is the graph of a cosine function. There you go, 2 cosine. Let's open up parentheses. The horrible parentheses, but it's okay. Now let's see the period. Okay, so the period is how often a graph will repeat. So starting up here, and we trace it down, and then trace it back up, and it repeats here. Okay, so this is the period, repeats here. So we see that from 0 up to pi. So this at pi, that's my period. My period in this case is pi is my period, and we know period is equals to 2 pi over b. Okay, what I can do here is just switch the pi and the b. So I'll have b equals, it's going to be 2 pi over pi, and the pi's are going to cancel out, so b is just going to be 2. Okay, b is 2. So we're not done yet. Well, we see the graph starts at the y-axis. There's no horizontal shift, so it's just going to be x. There you go, it's just x. I could have written parentheses and then x minus 0, but that whole thing just simplifies to x. That's that. Then one more thing, we need a vertical shift. Is there a vertical shift in this graph? Nope. The graph, the imaginary line that cuts this graph in half. Let me change this color. So the imaginary line that cuts this graph in half, it's right at the center. So that means that there is no vertical shift. the graph was not shifted either up or down, because the imaginary line it goes through the middle. Okay, if the imaginary line shifts up 1 unit, then that means that this graph was shifted up 1 unit. If it goes down, if the imaginary line goes down 1 unit, then this means that the graph was shifted down 1 unit. But the imaginary line that cuts the graph in half, it's at the center, so there was no vertical shift. So this is it. What we have here, this is the original graph. This is the original equation of this graph that we have here. Now we want to apply these transformations to this graph. Let's apply them and see what we get. Okay, so reflected over the y-axis. Okay, this is the y-axis. The other problem was a reflection over the x-axis. If we want to reflect over the y-axis, we take the variable, the x variable, and make it switch signs. So if it's positive to x, we'll just make it be negative to x. Let me see if I can erase something. Let's erase this work. We don't need it anymore. And let's go back to using black now. Okay, so my reflection over the y-axis, I'll make this negative. So it'll be negative, and it's going to be 2x. Okay. So there you go. That's my reflection over the y-axis. Then the next one, it's stretched by a factor of 4. Now again, it doesn't tell you if it's a vertical stretch or a horizontal stretch. So let's actually make this one be stretched by a again vertically. Okay, if it's stretched vertically, again it affects the amplitude. So it'll be 4 times 2, that'll make it 8. So we have an amplitude of 8. Let's put back in the cosine. Okay, and make it equals to y. I mean, this is supposed to be g. There you go. I'm sorry about the g that looks like a 9, but that's supposed to be a g. Okay. Then the last one we have shifted left pi units. So that's going to be making, I'm going to need my eraser, and I'm going to make this shift left. Let's make it go left pi units. So left, that means this is going to be plus pi. Now here I actually have to change this a little bit. Well, before I do that, let's do the shifted down 1 unit. That's just going to be the easiest one, just minus 1. Now I'm going to rewrite this because there's right now there's something wrong about this. It's just the way that I order it, it's wrong, but it has a simple fix. So equals the 8, the cosine. Now here's where the change occurs. Okay, the 2, that is the b, that's b. Okay, now the negative, because we have this pi now, the negative will actually go here along with x, because this negative next to x is my first one, my reflection over the y-axis. And then plus pi, and another parentheses, and then minus 1. Okay, so this is it. This is supposed to be a g. Okay, so this final one, that's my final answer. Okay, not this one, not this one up here, but this one. Okay, pretty much I use this one just like for scratch work, but this is gonna be my final answer. Because if you actually go to the equation back in our paper, on the original one, you can see that B is outside of the parentheses. Okay, that's why I rewrote this one to have B outside of the parentheses. All right, so this was the third problem from the study guide. That's pretty much it for those three, along with the explanation. Then let's see the other problems we have. We have pretty much these ones left over. 5, 6, and 7. It's telling you without a calculator or without calculation, explain why sine of 1.1 it's greater than sine of 0.3. So that should be pretty easy to explain. The other one, explain why cosine of 0.9 is greater than cosine of 3.1. Oh, in radians. Both of these are in radians. I gave you problems like this using angles and radians and combinations of angles and radians. So what we did in class was actually harder than this, but I'll explain it just for the sake of for you guys. Then we have this one. Janisha puts this into the calculator and she gets a result of 45 degrees. She knows that 135 also gives her also has a sine value of this. Explain why. Well, she's just using inverses in this one. She just used an inverse. That's pretty much all she did. Let me explain 7 first, because it's like the easiest one to explain. So 7, number 7, here he goes. It's pretty much, think about it. Let's say that that x squared equals 4. Okay, if x squared equals 4, that means that x equals 2. But then if you put 2 into, wait, no, if you take the square root of 4, you get 2. Well, this happens because the inverse of x squared is just the square root of x. Okay, so these are inverses. So you can say that this is the original f of x, and this is your f inverse of x. So you're just using inverses, okay? If you put the if you put this value into this, you'll get this in return. If you put the same value into the inverse, you also get this value. So she's just using inverses. All right, now the last two are gonna be sine of 1.1. We want to explain why it's greater than sine of 0.3. And the other one was cosine of 0.9, and why cosine of 0.9 was also greater than cosine of 3. And both of these problems are in radians. Okay, so both of them work under radians. Okay, so here's how it works. Looking at the unit circle, again, this is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi along with 0. Now remember that cosine is our x value, and sine is our y value. Okay, so the first one, it's focusing on y values. Okay, and what we have here, these are my radians. Okay, so 1.1 pi over 2, well, pi is 3.14, and divided by 2, that's like 1.6, kinda. You can say that this is like 1.6. So 0.9, if you start like going up, 0.9, it's wait, 1.1. 1.1, it's gonna be more than half. It's gonna be maybe somewhere here. This might be 1.1. Okay, if it was 1.5, it'll be closer. If it was 1.6, it'll be up here. It's 1.1, so this is about 1.1. 0.3, it's gonna be a little closer. There you go. So this is 0.3 radian, so this is like 1.1 radian. And now sine is a y value. Okay, this is a y value, this is a y value. So which one's higher, pretty much? Well, this one it goes more up than this one. So that's why this one is bigger than this one. Okay, because this one has a bigger y value. Now cosines, they are x values. All right, 0.9. So I can use the same circle. Let's change color. 0.9, that's gonna be like somewhere there. It's pretty close to 1.1. Now 3, on the other hand, 3 actually goes over to here. Remember that pi is 3.14. So it's pretty close here. Okay, so on the x values, 1.1 takes up, it's pretty much from here to here. I don't know the specific value, but I can say it's this value. And for the other point, it's from here to here. I know that the length of this is bigger and the length of this one's shorter, but this one's positive. 0.9 is positive, and at 3, this is negative. So that is the answer. That's why this one's also bigger, because this is a positive value and this is at a negative value. And that's it. That's the whole study guide. That's the whole test. Well, the study guide, the test has like almost the exact same questions. But with that, you can pretty much solve the test. Now, again, if you have questions on how to access the test, it's also on OneNote, and it's just here. All right. Same questions, same problems, same ideas. Try to understand. Please, please, please. Try to understand this. This will pretty much help you solve everything that you need to know for transformations of sine, cosine, tangent, and even for other trig equations. All right, so that's it for this video. Yeah, do your best on the test.